in combinatorics, next I will discuss dearrangement. What is dearrangement? How can arrange or how can permute that every object will be not in its place. That's called as dearrangement. A permutation or arrangement of n different objects in which no objects appear in its correct place called as dearrangement. In permutation we are arranging. In dearrangement every elements will be not in its proper place. Okay, so d of n equals to n factorial multiplication 1 divide 2 factorial minus 1 divide 3 factorial plus 1 divide 4 factorial minus 1 divide 5 factorial, like this, minus 1 power n divide n factorial. So this is the formula for dearrangement. Now check for this dearrangement of 2. D of 2. D of 2 equals to 1. Let A, B, and we have 2 place. Let 1, 2. Okay. So A should be placed in 1, B should be placed in 2. If we place A in 2, B in 1, then that's a dearrangement. Just we can do one dearrangement. A we can keep in B place, B we can keep in 1 place. And by formula it is 2 factorial as n equals to 2, 1 divide 2 factorial. So these 2 factorial will be cancelled. We will get 1. Next, D of 3. If we have 3 objects, how many dearrangements are possible? So it will be 3 factorial multiplication 1 divide 2 factorial minus 1 divide 3 factorial. Now simplify this. So 3 factorial. Here it's 2 factorial multiplication 3 factorial. Here 3 factorial. What is 3 factorial? It's 6 minus 2 factorial. 2 factorial is 2, right? So this 2 will be cancelled. 6 minus 2, it's 4. 4 divide 2, it's 2. So D of 3 equals to 2. Suppose we have 3 objects A, B, C. We have 3 place 1, 2, 3. So in one way A can be placed in 2, B can be placed in 3, C can be placed in 1. That is one dearrangement. Okay. Another dearrangement can be A, B, C, 1, 2, 3. So C can be placed in 2, B can be placed in 1 and A can be placed in 3. So that is another dearrangement. Suppose A will place in 3, C will place in 1, B will be placed in 2. Now B will be in its proper place, right? Dearrangement means no object will be in its proper place. That's why this is not possible. Only when every object placed in other place, that is the dearrangement. So D of 3 equals to 2. There are 2 possibilities. Okay. Next, D of 4. D of 4 equals to 4 factorial multiplication 1 divide 2 minus 1 divide 3 factorial plus 1 divide 4 factorial. So this 4 factorial value is 24. 1 divide 2 factorial is 1 by 2. 1 divide 3 factorial is 1 by 6. Now simplify this. So 24 here. 2 multiplied 12 is 24. 6 multiplied 4 is 24. Now 12 minus 4 plus 1. These two 24 will be cancelled. It's 8 plus 1 is 9. So D of 4 equals to 9. Next, D of 5. D of 5 equals to 5 factorial multiplication 1 divide 2 factorial minus 1 divide 3 factorial plus 1 divide 4 factorial minus 1 divide 5 factorial. So 5 factorial equals to 120. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. Now simplify this. So this thing will be 2 multiplied 60 is 120, right? 60 here. 6 multiplied 20 is 120. 24 multiplied 5 minus 1. And these 120 will be cancelled. So 60 minus 20, it's 40. 40 plus 5, 45 minus 1, 44. So D of 5 equals to 44. So just remember this dearrangement formula. Whatever value of n, you can simply put and find the value. Let's see one example. Example 16. 5 different letters L1, L2, L3, L4, L5 are to be placed in 5 envelopes. E1, E2, E3, E4, E5. One letter per envelope. How many ways we can place the letter into envelope so that first question, no letter is correctly placed. So there are 5 letters L1, L2, L3, L4, L5 and 5 envelope E1, E2, E3, E4, E5. First question, how we can place that no letter is correctly placed? Means we'll use D5. D5 value is 44, we know. So answer will be 44. Next, second question, at least one letter is correctly placed. So first number of way 5 letter can put into 5 envelope is 5 factorial. 5 factorial is 120. 20 and D arrangement of 5 is 44. Means no letter are correctly placed. So at least one letter is correctly placed means 120 minus 44. So 120 minus 44 is 76. So there are 76 ways that at least one letter is correctly placed. Next question, exactly two letters are correctly placed. Exactly two letters from 5 we can choose 2 in 10 way. We are using the combination formula 5C2 equals to 10. Remaining 3 can be D arrangement. So D of 3 equals to 2, right? 2 letters are correctly placed and 3 letters are wrongly placed. 10 multiplication 2, there are 20 ways that exactly 2 letters are correctly placed and 3 letters are wrongly placed. Next, fourth question, at most one letter is correctly placed. At most one means it can be either 0 or 1. So 0 means D of 5, 1 means one letter is correctly placed, rest 4 letters are wrongly placed. So for 0, D of 5, for one letter correctly placed, C5 1, from 5 we are choosing 1 multiplied by D of 4. D of 5 we know 44, so 44 plus 5 multiplied 9, it's 89. There are 89 ways that at most one letter is correctly placed. Next, at least one letter is wrongly placed. There is just one way, every letter will be placed correctly. Rest anywhere, at least one will be wrongly placed, right? So 5 factorial, that is 120 minus 1, 119. So there are 119 way that at least one letter is wrongly placed. 5 letter we can arrange in 5 factorial way. From that 5 factorial way, one way each every letter is correctly placed, right? That we are just subtracting. Next question, exactly one letter is wrongly placed. This is not possible. We have 5 letter L1, L2, L3, L4, L5 and E1, E2, E3, E4, E5. So exactly one letter is wrongly placed. Means suppose letter 3 we put in envelope 4. Okay. Then letter 4 will also be put in some different place, right? So there will be at least 2 letters who can be wrongly placed. Suppose L1 in E1, L2 in E2, L5 in E5, L3 we cannot keep in E4, right? So if we are keeping L3 in E4, then L4 we need to keep in E3. So for wrongly placed there should be at least 2. So this is not possible. So it is not possible to keep only one letter in wrong envelope, right? So there should be at least 2 letters which are put in wrong envelope. With this I am finishing D arrangement. For D arrangement you should remember that formula. In next lecture I will discuss inclusion exclusion. If this lecture is helpful for you, please like, share and subscribe. Thank you.